Hello everyone, today we are going to start our lecture number 6, Stoichiometry and mole concept. Before explaining what is stoichiometry and mole concept, I would like to remind you about a concept that you have also studied in your previous classes as well, that is law of conservation of mass. Law of conservation of mass. This law states that the amount of reactants are always equal to the amount of products in any chemical reaction. Okay, so this is on the basis of this law we can balance any chemical reaction. Say for example H2, when hydrogen react with oxygen, water will form. Okay, so we will, in order to balance this equation, we have to add somehow coefficients. Okay, coefficients are added with the formula. For example, there are 2 hydrogen and there is 2 oxygen. Here 2 oxygen are there, so we will write the coefficient 2. This is called the coefficient. Okay, so we will write this coefficient in order to balance this equation. Now if you see 2 mole of 2 molecule of water react with one molecule of oxygen, and as a result 2 molecule of water will form. Okay, so this is called stoichiometric coefficient. Okay, this is also called stoichiometric coefficients. So on the basis of law of conservation of mass, we will we will study that how stoichiometric coefficients, what is the rule of stoichiometry for balancing the chemical reaction. So if you see that stoichiometry can be defined the mole ratio of the reactants and products in a chemical reaction. The mole ratio, okay, hydrogen plus oxygen react with 2 molecule of water. So you can see over here the mole ratio of the reactants and the products. Okay, here mole ratio is 2 into 1 into 2 mole ratios. Okay, so this, when we write this coefficient, this represents the mole ratio of the reactant as well as the products. On the other hand, the mole concept, it says that the mole ratio of the products and reactants, these are always equal in any chemical reaction, and we have also did this by through this formula, that for example 2 mole of hydrogen, for example mole of hydrogen will be divided by its stoichiometric coefficients represented as Sc, and is equal to mole of oxygen divided by its stoichiometric coefficient is equal to the mole of water divided by its stoichiometric coefficient. This is the simple way of writing the mole concept, okay, or applying the mole concept on any chemical reaction for finding the unknown mass or for finding the unknown moles within any chemical reaction. Is that clear? So we also studied, on the other hand, that moles, okay, we have studied in moles in terms of weight. Okay, and its formula was that weight over molecular or molar mass. Okay, this was one formula, and moles for in terms of volume, which was volume of any solution, volume of any given solution in meter cube divided by its volume divided by its divided by 24 meter cube. Okay, we studied this in terms of volume. We studied this for gases. Okay, and the third one was concentration was equal to moles divided by volume of any solution in meter cube, and we also called the concentration as molarity. So moles here also represented by small n is equal to concentration of any solution multiplied by its volume in meter cube. Is that clear? So this three formula we can find the moles of any chemicals or products, and then after finding the moles we can easily calculate the weight. Is that clear? Now keep in mind three things, okay? That the moles of the reactants and the products, okay? For example, if I say that for example 2 mole of hydrogen, 2 molecule of hydrogen react with 1 molecule of oxygen, as a result 2 molecule of water is formed. For example, now here if I say that 1 mole of hydrogen, now here you can see over here 2 gram. If I convert this into if I all of them take as mole, then we will see that the weight of the hydrogen, that is weight of the hydrogen in 1 mole is 1 gram, and there are 2 atoms of hydrogen, 4 atoms. So 2 gram of hydrogen will react with 1632 gram of oxygen, and as a result 4 gram of oxygen, because 4 atoms of hydrogen are there. 2 atoms of hydrogen, oxygen 32 gram, and 2 molecule of water, 18 multiplied by 32, 33, 4, 5, 6, 36 gram of water molecule is formed. Now the interesting thing is that if we use the gram, okay, if we want to find or measure the amount of reactants and the products in terms of gram weight, okay, what will happen? The interesting thing is that both the weight of both the reactants and the products, it will become equal. But we cannot apply this in terms of moles, okay, because moles of the reactant cannot be equal to that of the products. Let's, for example, nitrogen plus hydrogen, okay, it will produce ammonia. Okay, now here there may be 1 mole of nitrogen, 1 mole of nitrogen, okay, now here 2 mole of hydrogen, H2, 2 mole of ammonia. Is that clear? 2 plus 1, 3, but here 2 moles, which is impossible, okay? So in the same way we cannot consider, we cannot add plus, okay? But in terms of the gram weight, in terms of weight, or in terms of finding the masses of the reactants and the products, they are always equal, because law of conservation of mass, okay, mass, this is not law of conservation of moles. Keep in mind, law of conservation of mass, okay? So the mass of the reactants and the products, they should be equal, okay, they should be equal, but we cannot apply this law of conservation of moles for the reactants and the products. So now coming towards the example, which is that of 35.6 gram of tin reacts with exactly 42.6 gram of chlorine to form 78.21 gram of stannic chloride. So calculate the number of moles of tin, chlorine, and tin chloride, and deduce the stoichiometry of the reaction. So chemical symbols are given for you. For example, chlorine reacts with tin, SN. They form the which compound? Stannic chloride. This stannic chloride or tin chloride. Now the amount of, or the weight of the chlorine, is given, that is 35.61, and that of tin is given, okay, tin is 35.61 and chlorine is 42.6 gram, and tin chloride 78.21 gram. So we have to calculate the moles, so we can easily convert them into moles, okay. Now there are 2 atoms of chlorine, so 42.6 divided by 2 atoms of chlorine, so here 35.5, okay, ratio. We cannot add the plus sign, because moles of the reactants and products, they cannot be equal. So stannic over here 35.61 divided by 10, mass of tin is 118.7, so here 1 atom of chlorine is 10. So on the other hand, tin chloride 78.21, and here 118.7 plus 35.5 into 4. So let's do the calculations. (71), so 42.6 divided by 71, it comes out to 0.6 moles. Okay, in the same way, 35.61 gram of the tin divided by 118.7, it comes out to 0.3 moles, and that of the 35.5 multiplied by 4, 142 plus 118.7, so it comes out to be 278.21. Will divide by 260.7, so 78.21 divided by 260.7, it comes out to be 0.3 moles. Okay, so you can, after that, you can easily moles, you can find the molar ratio. Second step is simplest molar ratios. Okay, so here's the simplest molar ratio. Here, mole ratio of the tin chloride moles is 0.3, 0.3 and 0.6. The smallest ratio is 0.3. So we'll divide all these three values with smallest number. So 0.6 divided by 0.3, 0.3 divided by 0.3, and 0.3 divided by 0.3. So definitely it will become 2 into 1 into 1. Okay, so here it was chlorine, here it was stannic and stannic tetrachloride. So 1, 1 and 2. So the equation is balanced. Okay, so we have calculated the stoichiometry of the reaction. We have balanced the chemical reaction through its mass. In the same case, another question on your book, that for example 56.2 gram of silicon reacts exactly with 284 gram of chlorine to form 340 gram of silicon tetrachloride. Use this information to calculate the stoichiometry of the reaction. In the first step, what will we do? In the first step, we will simply write the name of the symbols. Okay, silicon plus chlorine. We cannot balance it, okay, because we have to balance it through their given weights. So silicon tetrachloride. Okay, now in the second step we have to find the molar ratios of all the reactants and products. Now here we know that silicon weight is 56.2 gram. Okay, we know that moles, these are equal to weight in gram divided by molar mass. Now molar mass or atomic mass of the silicon is 28.1, and that chlorine, there are 2 atoms of chlorine in one molecule. So chlorine 284 divided by 35.5, and here silicon tetrachloride, weight of silicon tetrachloride is 340.2 gram divided by its 28.1, 1 atom of silicon plus 4 atoms of chlorine, 35.5. Okay, in the same case, after doing this, you will be able to find the molar ratios in the same way as we have done the previous question, that you can find the molar ratios, and then after finding the molar ratios, you will you have to find the simplest molar ratio. So 56.2 divided by 28.1, it comes out to be 2 ratio. Okay, now here again 35.5 multiplied by 2, it comes out to be 71. So 284 divided by 71, it comes out to be 4. Okay, then here 35.5 multiplied by 4 plus 28.1, 170.1. Now 340.2 2 divided by, it comes out to be 2. Okay, so these are the ratios. So simplest, this is the molar ratio. Okay, now in the third step we have to find the simplest molar ratios. Okay, simplest molar ratio. It means that we have divided all these three ratios with the smallest number. So 2 divided by 2, it becomes 1. Okay, and 4 divided by 2, it comes to be 2, and again 2 divided by 2 comes out to be 1. So 1 ratio 2 and 1. So 1 here, it was silicon. Okay, silicon 1 plus 2 chlorine molecule and 1 molecule of silicon tetrachloride. Keep in mind that we usually do not write the 1. Okay, while balancing any chemical reaction, we will not write 1. So another question is that 20 centimeter cube of metal hydroxide of concentration 0.06 mole diameter cube was titrated with 0.1 mole diameter cube of hydrochloric acid. It required 24 centimeter cube of HCl to exactly neutralize the metal hydroxide. So you need to calculate the number of moles of hydrochloric acid and metal hydroxide. So I will use the alphabet M for metal hydroxide, OH hydroxide, and when it reacts with hydrochloric acid, keep in mind that it is a neutralization reaction. Neutralization is a reaction in which acid base react together and they form salt. Here the salt is metal, chloride and water. Okay, so here metal hydroxide concentration or volume is 20 centimeter cube. Okay, so whenever the volume is given centimeter cube, we have to convert them into decimeter cube. So 20 multiplied by 10 raised to power minus 3 decimeter cube. Although keep in mind that always you try to use the standard form of writing the number. Standard form, okay, 10 raised to power minus 3 or 10 raised to power whatever. So because in this way you will do less mistake. Okay, so here 2 into 10 20 into 10 raised to power 3 minus 3, we can say 2 into 10 raised to power minus, so we can write 2 into 10 raised to power minus 2 decimeter cube. Okay, because we have removed 1 0. Okay, is that clear? 2 into 10 raised to power minus 2. In the same case, concentration, or in other words molarity, as given in the question, is 0.06 mole per diameter cube. So here if I write this in standard form, minus 2 mole per diameter cube. Okay, now this HCl volume is given, that is 24 centimeter cube multiplied by 10 raised to power minus 3 decimeter cube. Okay, so 2.4 into 10 raised to power minus 2 decimeter cube. Okay, so this is the overall volume of the hydrochloric gas. The same way concentration, which is concentration of hydrochloric acid, is 0.1 mole per diameter cube. I can also write this as 1 into 10 raised to power minus 1 mole per diameter cube. Is that clear? So in this, if I want to find the moles of metal hydroxide, is equal to its volume multiplied by concentration. Volume is 2 into 10 raised to power minus 2. Okay, and here concentration is 6 multiplied by 10 raised to power minus 2 as well. So 6 to 12 and minus 2 minus 4 moles. I can also write this in standard form as 1.2 into 10 raised to power minus 3 moles. Is that clear? In the second case, we can find the moles of the hydrochloric acid, which is equal to, its volume is 2.4 into 10 raised to power minus 2 volume, 2.4 into 10 raised to power minus 2, and concentration is given 1 into 10 raised to power minus 1. So 2.4 into 10 raised to power minus 3 moles. Okay, now if we compare the moles of the metal hydroxide, it was 1.2 into 10 raised to power minus 3 ratio, and that of hydrochloric acid was 2.4 into 10 raised to power minus 3. So which number is larger value? The larger number is of course 2.4. Okay, so we can find the molar ratio by dividing both the ratios with the smallest number. 1.2 into 10 raised to power minus 3. So it will cancel 1 into 2. Divide 2.4 over 1.2, it becomes 1.2. So here the coefficient of hydrochloric acid is 2. Okay, so if I want to write the equation HCl2 plus metal hydroxide, and I don't know the formula as well, so it will become metal chloride plus water. Okay, so there are 2 chlorine, so I will not write the coefficient over here, because if I write the coefficient over here, then in order to balance the equation, I also have to write the coefficient over here as well, which is impossible because the ratio of both the base and hydrochloric acid was 1 into 2 as we have calculated over here. So I cannot write over here the coefficient. So what I need to do, I need to bring change in the molecular formula. So here chlorine is 2, so 2 over here, and in this case 2 hydrogen and 1 oxygen. So there are how many hydrogen? 2. But okay, so in order to balance the equation, I will write 2 with this, and this equation become like this. Okay, so this is the stoichiometry, and we have balanced the equation. The same way, there is a question that 25 centimeter cube of 0.02125 multimeter cube solution of a metal hydroxide. Again, metal hydroxide was titrated with 0.04 multimeter cube of hydrochloric acid. It required 12.5 centimeter cube of acid to neutralize the hydrochloric acid. So we need to find the value of Y here. We need to find the number of atoms of oxygen and hydrogen. Y means number of atoms of hydrogen and oxygen. So after that, we have to write the balanced equation. So it means that we have to calculate the stoichiometry of the reaction. So hydrochloric acid, it gives definitely metal chloride plus water. Is that clear? Because whatever metal over here, this metal belongs to group 2 because its valence is +2. That's why hydroxide is -2, and they will exchange their charges. Here chlorine is -1 and +2, -1. They will exchange their valences. So now moles of the metal hydroxide, okay, this compound, we have to find the moles, and the concentration is given. Concentration of this is given as 0.0125. If I want to write this in standard form, I will write 1.25 into 10 raised to power 2 minus 2 mole per diameter cube, and its volume is given, which is 25 centimeter cube, which is equal to 2.5 into 10 raised to power minus 2 diameter cube, because 25 divided by 1000, it will become in this way, standard form. Okay, so number of moles is equal to volume multiplied by concentration, 1.25 into 10 raised to power minus 2. So 1.25 multiplied by 2.5, 1.25 multiplied by 2.5, it comes out to be 3.125 into 10 raised to power minus 4. Is that clear? So these are the moles of the metal hydroxide. On the other hand, hydrochloric acid, we also need to find the moles, and its volume is given, that is 12.5 centimeter cube. 12.5 multiplied by 10 raised to power minus 3. We can also write 1.25 into 10 raised to power minus 2 decimeter cube. So, and concentration of hydrochloric acid is 0.05 mole per decimeter cube. I can also write this 5 into 10 raised to power minus 2 mole per decimeter cube. So the moles comes out to be 5 into 10 raised to power minus 2 multiplied by volume 1.25 into 10 raised to power minus 2. So 1.25 multiplied by 5, 6.25 into 10 raised to power minus 4 moles. Is that clear? So these are the moles of the hydrochloric acid. Now let's do the stoichiometry. Here the moles of the metal hydroxide, these are 3.125 into 10 raised to power minus 4, and moles of hydrochloric acid is 6.25 into 10 raised to power minus 4. Is that clear? So we have to find which number is the smallest value. Which one is the smallest value? And this way, for molar ratio, we have to select the smallest value, that is 3.125 into 10 raised to power minus 4. This were the moles of the metal hydroxide into HCl, and that HCl mole was 6.25, which is larger value, into 3.125. We will multiply this with both the ratios with the smallest value which is present in the ratios. So it comes out to be 1 into 6.25 divided by 3.125, 2. So 2 is the coefficient of HCl. So I will write HCl 2, metal XOH plus water. Now if you see 2 hydrogen over here, so chlorine 2, and hydrogen must be 2 over here. 2 over here in order to balance the equation. So we find the formula of this unknown compound with the help of the stoichiometry. This X metal may be belong to A group. Okay, this can be any metal related to A group. That is, it might be calcium, it might be magnesium, it might be beryllium, strontium, and radium. Is that clear? This X can be any metal related to group 2A, because all the valency of the group 2 is +2, and we know that charge of hydroxyl ion is -1. Is that clear? So definitely they will exchange their valency, and we know that charge of the chlorine is -1 and charge of hydrogen is +1. Is that clear? So here hydrochloric acid HCl 1,1, but here chlorine Cl2. Okay, because this metal, it belongs to group 2A. Okay, because of its valency, we calculate the stoichiometry, we balance the chemical equation. Okay, the same type of question. Now it's come towards the gases. Now we have to calculate the stoichiometry of the gases. Okay, very important. We know that gases, number of moles is equal to given volume divided by 24. Okay, 24 decimeter cube. That given volume, first of all we have to convert them into decimeter cube if it is given in centimeter cube. Then after that we will divide the value of volume into 24. Now the question which is given in your book, 50 centimeter cube of a gaseous hydride phosphorus, PHN, reacts with exactly, so PHN, here again we do not know number of atoms of hydrogen. So PHN reacts with exactly 150 centimeter cube of chlorine gas to form liquid phosphorus trichloride, 3-chlorine, and 150 centimeter cube of hydrogen chloride. Okay, so here gaseous hydride phosphorus, it is 50 centimeter cube, chlorine is 150, and here hydrochloric acid is also 150. Okay, now for this, the value, all of the values are given in a very small value, that is centimeter cube. We have to convert them into decimeter cube. So 50 into 10 raised to power minus 3, 150 into 10 raised to power minus 3, 150 into 10 raised to power minus 3, because I divide all these three values of the volume by 1000. Minus 3 mean that I divide all these three value with 1000. So after that, number of moles, these are, we have to divide 50 into 10 raised to power minus 3 divided by 24, 150 into 10 raised to power minus 3 divided by 24, and the same 150 into 10 raised to power minus 3 divided by 24. So the molar ratios would come out to be 50 divided by 24. Into 10 raised to power 2.1 into 10 raised to power minus. So if we for molar ratio, definitely we will select any smallest value in the ratio and then divide all these three ratio with that smallest value. At the end we will get 1 into 3 into 3. So the coefficient of the chlorine would be 3 and that coefficient of hydrochloric acid would be 3. By putting the values in the equation, we will get 3 mole of chlorine and 3 molecule of hydrochloric acid. But if there are 3 hydrogen, so we can easily find the number of hydrogen atoms, because n it was required in the equation, so we will write 3 instead of n in the equation. So the next question is that molecule butene is given for us, and CXHY means both the number of atoms of carbon and number of atoms of hydrogen, both of these are unknown, and the volume of this gas is 14 centimeter cube. So this butene gas, okay, in which we do not know the number of carbon and hydrogen, this react with 84 centimeter cube of oxygen. Okay, so oxygen gas, okay, O2, because we know that oxygen occurs in the form of O2 in the when it is in gaseous state. So it reacts with carbon dioxide, oxygen. As a result, carbon dioxide is formed, and the formula of carbon dioxide is CO2. So reduce the formula of butene should all working. So definitely, now keep in mind that this equation is a combustion type of reaction. Combustion means it is something is burning. Okay. In other words, oxidation. Oxygen is being added with carbon and hydrogen is being removed. Okay. So whenever there is a combustion, when we are burning something, what happens that water is also formed. Okay, water is also produced. So when something is burning, carbon dioxide and water is produced. Okay, so here we need to find the number of atoms of carbon and hydrogen in this butene molecule, as well as we have to balance the equation with the help of their given amount of volume. So now starting from this butene, okay, starting from here, its volume is 14 centimeter cube, and I want to convert this into decimeter cube, so definitely 14 into 10 raised to power minus 3 decimeter cube. Is that clear? And it would almost become 1.4 into 10 raised to power minus 2 decimeter cube. Okay, because in writing in standard form, you just need to write the point after one after the first number. In the same way, volume of this is given for us, and volume of oxygen is also given, and its volume is 84 centimeter cube, and its volume become 8.4 into 10 raised to power minus 2 decimeter cube. Okay, now moles of butene, that is given volume divided by 24. Okay, so given volume is 1.4 of butene into 10 raised to power minus 2 divided by 24. So 1.4 divided by 24 comes out to be 0.05 into 10 raised to power minus 2, 583. I can further write this as 5.83 into 10 raised to power minus 4. Is that clear? And moles of oxygen gas. Okay, oxygen gas, moles of oxygen gas is 84. So 8.4 into 10 raised to power minus 2 will divide by 24. So 8.4 divided by 24, 0.35 into 10 raised to power minus 2. I can also write this 3.5 into 10 raised to power minus 3 moles. Okay, and carbon dioxide, we have forgot about carbon dioxide, so let's calculate its value as well. Volume of carbon dioxide is 56 centimeter cube. It comes out to be 5.6 into 10 raised to power minus 2 decimeter cube, and its mole would become 5.6 into 10 raised to power minus 2 over 24. So 5.6 divided by 24, 0.23 is equal to 0.233 into 10 raised to power minus 2. So here CXHY plus oxygen gas, in which we do not know their stoichiometric coefficient. Here carbon dioxide gas plus water vapors are produced. Moles of butene, these are almost 5.83 into 10 raised to power minus 4. Moles of oxygen, these are 3.5 into 10 raised to power minus 3, and moles of carbon dioxide, these are 0.33 into 10 raised to power minus 2. I can also write this 2.33 into 10 raised to power minus 3. Now if you see this, the smallest value over here is that of butene, smallest mole. Okay, so we will divide all these three ratios with this smallest value, 5.83 into 10 raised to power minus 4, 5.83 into 10 raised to power minus 4, and 5.83 into 10 raised to power minus 4. So definitely it will become 1. So 3.5 divided by 5.83, 0.6 into 10 raised to power plus 1, because here minus 4, when it comes moving towards the upside numerator, what will happen? It will become plus 4 minus 3, so 0.6 into 10 raised to power 1. Okay, so it comes out to be 6. Okay, and here 2.33 divided by 5.83, it comes out to be almost 4, yes, 0.399 into 10 into 10. So I can write over here 1 into 6 into 3.99 is almost equal to 4. Is that clear? So the ratio becomes this 1 into 6 into 4. So this 4 was belonged to, if I write the equation, this 4, it was related to carbon, okay, and 6 oxygen, and here 1. Okay, now let's balance the equation. 4 carbon over here, but here carbon is, number of carbon X would become 4. Is that clear? And 6 to 12. Okay, 12 oxygen are here on this side, and on this side 4 to 8 oxygen. How many oxygen are required? So I need over here almost 4, because 8 plus 4 is equal to 12. 4 to 8. So 8 had a hydrogen atom over here and 8 would become here. So 4 oxygen here and 8 over here. 8 plus 4, it becomes 12 oxygen. So if I want to rewrite the equation, C4H8 plus 6 molecule of oxygen, it gives out 4 molecule of carbon dioxide plus 4 molecule of water. So this is how we have balanced the equation, and we have also found the molecular formula of butane with the help of this stoichiometric equation. Okay, so this is how you can calculate the moles, and you can balance the equation for through stoichiometry by applying the mole concept. Okay, so again I will repeat that stoichiometry. Okay, stoichiometry, which is based on mole concept. Okay, it is basically used to balance the chemical reaction. Okay, and also used to find the molecular formula. Okay, and it's also used to find the masses, moles or volumes of reacting masses of reactants as well as products. Is that clear? So this is the purpose of stoichiometry, and I hope that you have understood the concept, and I hope that you have also know how to apply the mole concept on stoichiometry, and in this way you can calculate the masses and volumes and find the molecular formula of the reactants as well as the products.